Good morning, everyone. It is truly a great pleasure and an honor to be here at the very first International Conference on Leadership in AI. This event is an incredibly remarkable initiative. It is held under the far-reaching umbrella of the International Conferences in Computational Science and Engineering for Society. It serves as a truly unique platform where thinkers, researchers, and industry experts from all around the world come together. When you walk into this conference venue, you can see a bustling scene. Experts from different corners of the world, with diverse backgrounds and cultures, are chatting and exchanging ideas. Some are engaged in passionate debates, gesturing with their hands to emphasize their points. Others are sitting quietly, taking notes as they listen intently to what their peers have to say. They gather here to share their diverse ideas and drive innovation in the exciting field of AI. My name is Gabriel Silva-Atencio. I'm really excited to stand in front of you all today and present my in-depth research. The title of my research is an integrated governance framework for trustworthy AI, bridging ethics, risk, and accountability. As we all clearly witness, artificial intelligence is no longer a distant, abstract concept. It has rapidly and deeply become an inseparable part of our daily lives. It's like a thread that is intricately woven into the very fabric of our society. Just think about it. From the moment we wake up and check our smart devices, which have become an extension of ourselves, to the advanced medical diagnostics used in hospitals, where AI can detect diseases at an early stage, AI is truly everywhere. Consider our morning routine in more detail. When we wake up, we might use a smart alarm that uses AI to analyze our sleep patterns and wake us at the optimal time. The alarm not only wakes us up, but also provides us with information about our sleep quality, such as how long we were in deep sleep and how many times we woke up during the night. And when we look at our phones, the news feed is personalized by AI algorithms, showing us content that is most relevant to our interests. These algorithms take into account our past reading habits, the topics we've searched for, and even our location to curate a news feed that is tailored to us. With this widespread and rapid integration of AI, the challenge of ensuring that these systems are trustworthy has never been more urgent and critical. It's not just about having AI systems that can perform tasks. It's about having AI that we can wholeheartedly rely on. We need AI that is fair, accountable, and transparent. For example, in the financial sector, AI-driven lending algorithms should not discriminate against certain groups. In healthcare, AI-based diagnostic tools should be accountable for their results. Take the financial sector as an example. AI-driven lending algorithms are used to assess creditworthiness. However, if these algorithms are based on biased data, they may wrongly reject loan applications from certain groups, such as minorities. This is a serious problem that needs to be addressed. We can further explore how these algorithms are developed. Data scientists collect large amounts of data, including information about borrowers' income, credit history, and employment status. But sometimes, this data may contain hidden biases. For instance, if historical data shows that certain neighborhoods have a higher default rate, the algorithm may unfairly penalize applicants from those areas, even if they are creditworthy. My work is centered on a very important shift. Traditionally, a lot of discussions in AI ethics have remained at a high level. They mainly focus on the what of AI ethics. We often talk about the broad ethical principles like fairness and privacy, but we often struggle to move from these abstract concepts to the practical how of organizational implementation. How do we actually make sure that companies and institutions can put these ethical principles into action when developing and deploying AI systems? For instance, how can a tech startup ensure that its AI-powered recommendation system respects user privacy? Let's think about a tech startup in more detail. A startup may have limited resources, but it still needs to ensure that its AI-powered recommendation system does not collect or misuse user data. This requires the startup to have a clear understanding of privacy laws and ethical guidelines, and to implement appropriate technical measures. The startup might need to hire a privacy expert to review their data collection and storage processes. They also need to ensure that their algorithms are designed in a way that protects user privacy, such as using techniques like differential privacy. Over the next 20 minutes or so, I'm going to take you on a detailed journey. First, I'll start by diving deep into the current implementation gap. This gap is a significant and pressing issue in the field of AI governance. It's like a wide chasm between the theoretical ethical ideals and the real-world application of AI systems. To better understand this, let's consider the case of autonomous vehicles. The ethical ideal is that these vehicles should prioritize the safety of all road users. But in real-world development and deployment, there are many challenges in translating this ideal into actual practice. For example, autonomous vehicles may face complex situations on the road, such as pedestrians crossing the street suddenly or other vehicles driving erratically. How can the AI in these vehicles make the right decisions in these situations? This requires not only advanced technical algorithms, but also a deep understanding of ethical principles. We can also think about the testing process of autonomous vehicles. Developers need to simulate a wide range of scenarios to ensure that the AI can handle different situations. They need to test the vehicles in various weather conditions, different traffic densities, and with different types of road users. Then, I'll introduce you to the interdisciplinary methodology that I've used to address this gap. This methodology is not just about one single approach. It combines knowledge and techniques from different fields, such as computer science, ethics, law, and business management. By bringing these diverse perspectives together, we can develop a more comprehensive and effective solution. For example, computer science can provide the technical tools to build AI systems, while ethics can guide the design to ensure fairness. Law can set the regulatory boundaries, and business management can help in the implementation and operation of these systems. When we develop an AI system, computer scientists are responsible for writing the code and optimizing the algorithms. Ethical experts can review the design to ensure that the system is fair and unbiased. Lawyers can help us understand the legal requirements and ensure that our system complies with the law. And business managers can ensure that the system is implemented in a way that is cost-effective and beneficial for the organization. Let's take a closer look at how these different fields interact. Computer scientists need to work closely with ethical experts to ensure that the algorithms they develop are fair. For example, they may need to use techniques like algorithmic auditing to check for biases in the code. Ethical experts can also provide guidance on how to design the system to respect user privacy. Lawyers can be involved from the early stages of development to ensure that the system complies with relevant laws and regulations. Business managers need to coordinate the efforts of all these different teams to ensure that the project is completed on time and within budget. Finally, I'll present the integrated framework that I've developed. This framework serves as a detailed blueprint for operationalizing AI governance. It's designed to be both rigorous, ensuring that all ethical and risk management requirements are met. At the same time, it's adaptable to the ever-changing modern technological demands. In the following sections, I'll explain each part of the framework in detail. I'll give you real-world examples so that you can clearly see how it can be applied in real-world scenarios to create trustworthy AI systems. For example, in the context of a large e-commerce company, how can this framework be used to manage the AI algorithms that recommend products to customers? In a large e-commerce company, the AI algorithms for product recommendation are crucial for increasing sales and customer satisfaction. Our framework can help the company ensure that these algorithms are fair, for example, by not promoting certain products over others based on unfair criteria. It can also help the company manage the risks associated with these algorithms, such as the risk of data leakage or the risk of providing inaccurate recommendations. Let's dig deeper into the e-commerce example. The company may have a large amount of customer data, including their purchase history, browsing behavior, and demographic information. The AI algorithms use this data to recommend products. But there is a risk that these algorithms may promote products based on factors like the company's profit margin rather than the customer's actual needs. Our framework can help the company set up a system of checks and balances. For example, they can have an independent review board that monitors the algorithm's performance and ensures that it is fair. They can also implement security measures to protect the customer data from leakage. To begin, let us define the core problem, the AI implementation gap. While there is a global consensus that AI must be trustworthy, achieving this goal remains elusive. We see AI systems being increasingly deployed in high-stakes domains like healthcare, finance, and law enforcement, where the cost of failure is high. Consequently, the academic and public discourse has shifted from broad ethical principles to hard regulation, most notably seen in the EU AI Act. However, the current landscape is fragmented. Technical research into fairness, accountability, and transparency, often called FACT, tends to operate in isolation from organizational governance. On the other hand, traditional business risk management frameworks are not designed for the adaptive and probabilistic nature of modern AI systems. Furthermore, ethical principles often remain abstract and lack the binding force needed to influence design decisions. This results in a significant gap. There is no integrated architecture to translate normative commitments into auditable controls and demonstrable accountability. My research aims to fill this specific void. When we look at the existing literature, we find three siloed conversations that rarely intersect effectively. First, the AI ethics literature provides a consensus on principles like fairness and transparency, but it is criticized for lacking context and binding force for actual engineering design decisions. Second, the technical FACT research provides advanced tools for bias detection and explainability, yet these often operate as one-off solutions, rather than being integrated into the broader organizational governance structure. Finally, the management and GRC literature, standing for governance, risk, and compliance, offers models built for traditional IT environments. These models struggle to handle the inherent uncertainty, data dependencies, and emergent behaviors of machine learning systems. What is missing is a link, a unified framework that synthesizes these three distinct perspectives into a coherent, lifecycle-oriented governance design. We need a system that speaks the language of the ethicist, the engineer, and the compliance officer simultaneously to ensure a truly holistic approach to AI safety. This leads to my central research question. How can a unified governance framework be designed that integrates ethical principles, technical accountability, and organizational risk management for trustworthy AI? To answer this, I propose a three-part integrated artifact. The first component is an AI-tailored GRC model, which adapts traditional enterprise risk management specifically for AI-related risks. The second is a multi-stakeholder transparency protocol that moves away from one-size-fits-all disclosure toward risk-based, tiered transparency. The third component consists of algorithmic accountability mechanisms, establishing clear roles, documentation standards, and redress procedures. The key innovation here is not just the components themselves, but how they are linked. They operate in a continuous control loop where risk assessments determine the required level of transparency, and accountability checks feed directly back into the compliance process. This ensures that the governance framework is not a static document, but a living system that evolves alongside the technology it monitors. In terms of methodology, this research follows the design science research approach, which is ideal for creating and evaluating innovative IT artifacts meant to solve complex organizational problems. The framework is built upon an interdisciplinary knowledge base drawing from computer science for FACT tools, law for regulatory requirements like the EU AI Act and ISO 42001, management studies for GRC models, and science and technology studies for governance theory. Three core design principles guided the development: holistic integration, ensuring that technical, legal, and organizational controls work together; dynamic compliance, providing lifecycle-based governance for adaptive systems; and stakeholder utility, making sure the outcomes are useful for developers, regulators, and end users alike. The evaluation of this framework was based on its conceptual soundness, its alignment with emerging international regulations, and scenario-based testing to ensure its practical logic holds up under the pressures of real-world deployment scenarios. Now, let's look closer at the result. The three-part integrated framework. This architecture is built on three interlocking components that cover the entire AI lifecycle. Component 1, the AI-tailored GRC model, extends traditional governance to include specific algorithmic risk vectors such as data provenance, model drift, and emergent behavior. It utilizes a two-stage risk assessment process that combines technical evaluation with a societal impact assessment, resulting in a combined risk score. Component 2 is the multi-stakeholder transparency protocol, which defines 4 levels of disclosure: public, user-facing, auditor, and developer, specifying the content and timing for each. Finally, Component 3 is the algorithmic accountability system. This includes a responsibility assignment matrix to clarify who is accountable for model accuracy or fairness, a living AI governance file as a single source of truth for all artifacts, and formal redress mechanisms that allow individuals to contest automated decisions and request human review. Together, these form a comprehensive shield against AI-related risks. The first major innovation I want to highlight is the transition from static compliance to dynamic risk management through AI-tailored GRC. Traditional GRC is often a check-the-box exercise conducted at the start of a project. However, AI systems are not static. They change as they process new data. Our solution uses a two-stage assessment. First, a technical model risk evaluation looks at accuracy, robustness, and explainability. Second, a societal impact assessment looks at fairness and potential harm to stakeholders. The outcome is a combined risk score that dynamically determines 3 things: the required transparency level, the rigor of accountability controls, such as how often the model must be audited, and the intensity of monitoring. This proportionality is crucial. It ensures that low-risk applications are not burdened by excessive bureaucracy, while high-risk systems receive the intensive oversight they require. This makes governance a facilitator of innovation rather than a barrier, by focusing resources where they are most needed. The second innovation is the multi-stakeholder transparency protocol. A common problem in AI today is that generic transparency is often meaningless. A deep technical log is useless to a consumer, while a high-level ethical statement is useless to a regulator. Our protocol solves this by establishing 4 levels of disclosure. At the public level, we provide high-level policies and ethical commitments. For the user-facing level, we focus on information about how automated decisions are made and how they can be challenged. At the auditor and regulator level, we provide detailed technical documentation, including model cards and full audit trails specifically aligned with the evidence requirements of the EU AI Act. Finally, at the developer level, we maintain internal documentation for troubleshooting and handovers. By linking transparency to specific audiences and risk levels, it ceases to be a vague ideal and becomes a targeted governance tool that provides the right information to the right people at the right time. The third innovation addresses the fragmentation of responsibility in AI supply chains. Often, when an AI system fails, it is unclear who is responsible: the data provider, the model developer, or the end-user organization. Our algorithmic accountability system makes accountability real through roles, records, and redress. We utilize a responsibility assignment matrix that maps specific roles to accountability for model accuracy, fairness, and incident management. All governance data is aggregated into a living AI governance file, which serves as a single auditable repository for risk assessments and performance logs. Most importantly, we include formal redress mechanisms. This gives individuals the right to contest automated decisions and a guaranteed timeline for a human response. This creates a permanent chain of answerability across the entire AI lifecycle, ensuring that there is always a human in the loop who is responsible for the system's outcomes and capable of correcting errors when they occur. What truly brings this framework to life is what we call smart engineering, the continuous control loop. The components are not meant to be static silos, they are the engine of governance. The process begins with the GRC identifying risks and assigning a risk score. This score then automatically determines the necessary level of transparency and the strictness of accountability mechanisms. As the system operates, these mechanisms, such as audits and incident reviews, generate real-world evidence and performance data. This evidence then feeds back into the GRC process, allowing for an updated risk assessment. If a model begins to drift or show bias post-deployment, the loop detects this, updates the risk score, and may trigger higher levels of transparency or more frequent human reviews. This creates a living system that adapts as the AI evolves, directly addressing the challenge of post-deployment model drift and emergent behavior. It ensures that the governance remains effective throughout the system's entire operational life. To ensure the validity of this framework, we evaluated it against several key criteria. Conceptually, it meets the design science requirements for internal consistency and completeness, directly addressing the implementation gap identified in current research. From a regulatory standpoint, the framework is mapped directly to the requirements of the EU AI Act, including risk classification and post-market monitoring. It is also aligned with the ISO 42001 standard for AI management systems, providing a practical bridge between abstract legal texts and day-to-day operational practice. We conducted scenario-based testing by applying the framework to various high-risk use cases. These tests demonstrated how the operational logic holds up, showing how risk scores can dynamically and appropriately adjust transparency and accountability controls in a way that is logical and manageable for an organization. This validation proves that the framework is not just theoretically sound, but practically relevant for organizations navigating the complex regulatory landscape of the near future. In conclusion, this study presents what we believe is the first truly integrated, lifecycle-oriented governance framework that synthesizes GRC, transparency, and accountability for AI. The key innovations, the dynamic risk scoring, the four-tiered transparency protocol, the algorithmic accountability system, and the continuous control loop, provide a comprehensive blueprint for any organization looking to operationalize trustworthy AI. Our central insight is that trustworthy AI cannot be achieved through ethical principles or technical tools alone. It requires a socio-technical governance system that explicitly links ethical commitments to auditable controls. Of course, there are limitations. This framework assumes a certain level of organizational maturity and depends on the availability of supporting technical tools for monitoring. Looking ahead, we plan to conduct longitudinal case studies and extend this framework to address the unique challenges of generative AI, including content governance and system safety. Thank you for your time and attention. I look forward to your questions.